So I've already made a video explaining several of these questions. We're going to keep working on it. This is another video explaining more questions. Now, we need to remember that when you solve a radical equation, you have these steps that we need to go through. Step one is to isolate the radical, right? You want to get the radical by itself, whether it's a square root, cube root, fourth root. You want to get that by itself on one side of the equation. Step two is to get rid of that radical by applying an exponent, by applying a power to both sides. And it's going to be the exact value of the radical. So like if you have a square root, you're going to apply a square on both sides. If you have a cube root, you're going to apply the power of 3 on both sides. A fourth root, you're going to apply the power of 4 on both sides. And then after that, you solve it, and then of course check your answers. So Liam, you said you wanted to do 15. Step one is to isolate the root, to get it by itself. That root, this square root, is on the left side of the equal sign. It's not by itself. There's a minus 3 right there. I need to get rid of that minus 3. What do I do? Plus 3. Plus 3. What do I have left? I have the square root of 2t minus 5 equals 6. That is step one of isolating the radical. Step two is to get rid of that radical. Okay? So we've isolated it. Now let's get rid of it by applying a power. Because this is a square root, we're going to apply the power of 2 to both sides. If this would have been a cube root, I'd be applying the power of 3. If it were a fifth root, I'd be applying the power of 5. Whatever root is there, you're going to have to apply that power to undo that root. So what do we have here? We have 2t minus 5 equals 36. 2t minus 5 equals 36. And then we continue to solve by going plus 5, plus 5. We have 2t equals, what is that, 41? And we're going to divide by 2 at the very end. And we end up with t equals 41 over 2. T equals 41 over 2. And that is your answer, but you have to test your answer to see it, make sure that it works. Now, you could have written this as 20.5. However, this fraction's nice when you plug it back in, because when you do 2 times 41 over 2, the 2's cancel out and you end up with just 41, right? Or do I need to show that? You want me to show that? Okay, so here it is, the same radical, but I'm actually plugging in the answer 41 over 2. The 2's are going to cancel, and 41 that's left over, take away 5, that's 36. So I really have the square root of 36 in here. And the square root of 36 is 6, and if you take away 3 from the 6, take away 3, it really does equal 3. That's what we call double checking our answer. So it does work, so the answer is 41 over 2. That's the answer that should be on the back. Cool? Again, same process. You want to isolate the radical first, get rid of the radical by applying a power on both sides, and solving and then testing your answer. Which other one would you like to see? Sophia, which one? 25? Okay, and then we'll go back to 19 if you need it. Actually, 19 is explained on a different video if you want to watch that other video. 25, it's also explained on a different video. How about one that's not explained? 23, 26, 28. 21. So if we look at 21, a lot of people get confused on this one because step one on solving an equation is to isolate the radical. And right here, the radicals are already isolated, right? So you move on to step two, get rid of the radical by applying a power on both sides. So the square root, to get rid of it, you're going to have to apply the power of 2 on both sides. And magically, the square roots disappear. You end up with a nice, beautiful equation. 6x minus 4 equals 2x plus 10. Yeah, it's so easy that some people get confused. After that, it's just an algebra 1 problem where you subtract 2x, move it to this side. You end up with 4x minus 4 equals 10, plus 4 plus 4. You end up with 4x equaling 14. Dividing by 4, you end up with x equaling 14 over 4. Did I do something wrong? I don't know. That's our answer. You could reduce that answer to 7 over 2. Okay? Let's actually do that. X equals 7 over 2. But you still need to test the answer, because just because you get an actual answer doesn't mean that's right. We need to do step 3, which is test the answer. So take that 7 over 2, plug it right here, and that'll be 6 divided by 2 is 3. 3 times 7 is 21 minus 4. It's 21 minus 4. 18. And then over here, if you plug in 7 halves, it'll be, wait, we said 18 right here? 17. Okay, and then over here, when you plug in 7 halves, 2 times 7 halves is 7. 7 plus 10 is 17 also. So you will get the square root of 17 equals the square root of 17, which is correct, which means that 7 halves is the correct answer. I did not show my work plugging it back in, but you need to plug it back in to verify. So the answer is 7 halves. I hope that's what you see on the back. So anytime you have 2 radicals on both sides, it's really easy. You just square both sides, and you end up with your equation 4r minus 6 equals r. And then you just solve it the way you normally would. But you got to test your answer to make sure that you're right. Now, when you get to the second half, this is where you have to solve inequalities, all right? And solving inequalities, it's the same thing as solving equations. There's just an extra step you need to do. Now, I always say start with the first step, which is setting this to be greater than or equal to 0. But you don't have to do that. You could just treat it like an equation and just solve it, right? So if I wanted to solve this guy, I would first make sure that it's isolated, which it is. I would then apply a power of 2 to both sides, and you'd end up with 2a minus 3 is less than 25, plus 3, you end up with 2a is less than 28. Final step, divide by 2, a is less than 14. That's one answer. The other answer comes from the inside of the root. Because it's an inequality, you need to make sure that this is greater than or equal to 0. So you actually set that greater than or equal to 0. You set it greater than or equal to 0, and then you solve it, and that's your other answer.
Yeah. When you do it, you switch the sign?
It's not that you switch the sign, it's that this inside radical value has to be positive. Because if it were less than 0, you end up with a negative inside a square root, which makes it imaginary. So that's why whenever you have a square root or a fourth root or a sixth root, you have to take the inside value and set it to be greater than or equal to 0. Okay. If you had a third root, you wouldn't have to do this extra work, because you could actually have negative values inside of the third roots. The third root of negative 8 is negative 2. But right here, you have to have this to be greater than or equal to 0 because it's a square root. And when you solve it, you end up with 2a is greater than or equal to 3. So you'd have to divide by 2, a is greater than or equal to 3 over 2, which is 1.5. So you still need to test your answer and either write it as a compound inequality if both of them are working, if they're working together. The best way to do that is to think of a number line, bless you. If you put 3 halves right there, 14 would be over here. So a is less than 14. 14 less than is that way. A is greater than or equal to 3 halves, greater than or equal to is that way. So we're assuming, what this answer shows, the graph or the sketch, it shows that our answers are between here and here. Now we need to test and make sure and verify that that's correct. So let's pick a value that I could plug in here between 1.5 and 14. Give me any number you want from here.
0.
0 would be on the outside, right?
1.
Okay, 7. Let's plug in 7. If we plug in 7 right here, it's going to be 2 times 7, which is 14. And then 14 take away 3, that's 11. And the square root of 11 is definitely less than the square root of 16, right? The square root of 11 is about 3 point something. So 3 point something is definitely less than 5. So we see that that does work. If I would have picked 0, like you said, which is on the outside, it's not going to work. 2 times 0 is 0. 0 minus 3 is negative 3. The square root of a negative is imaginary. So you can't say that an imaginary is less than 5. Imaginary is something else. So that's why out here 0 does not work. Okay? 0 doesn't work. This one, yes, it worked. When we tried 7, it did work. If you pick a number that's bigger than 14, it's not going to work. Pick something like, let's just say 20. You'd say 2 times 20 is 40. 40 take away 3 is 37. Square root of 37 is a little bit more than the square root of 36, but square root of 36 is 6, and 6 is definitely not less than 5. So out here it doesn't work also. So because we tested it, because we saw that the areas really are together and it does work in the middle, we are going to write this as a compound inequality written together with the x in the middle, smaller number 3 halves on this side, bigger number 14 on this side, with the inequalities where the one on the 14 did not have a solid line underneath it, but the 3 halves did have. So this is your answer. Compound inequality, 3 halves is less than or equal to x, which is less than 14. So just to reiterate, when you have an equation, what are we doing? First, isolate that radical, and then get rid of the radical. How do you get rid of a radical? If it's a third root, you do use a third power. If it's a fourth root, use a fourth power. That's solving an equation. But if you have an inequality, you want to set the inside of the radical to be greater than or equal to 0. That's one problem in itself where you're going to get one answer. Okay? Set the inside of the radical to be greater than or equal to 0. And again, that's only if you have an even root, like a square root. And on all of these are square roots, so you're going to have to do this on all these, I believe. So you set the inside of the radical to be greater than or equal to 0, and you solve it, you get an answer, and then you go back and solve the entire thing as if it were an equation instead of an inequality. You get another answer, draw your number line, test your answers, and write it as a compound inequality if you have to. Okay? So what do you guys say? Any other one you'd like to see from here? From this worksheet? Any other work? Anyone want me to explain any other question on this worksheet? Okay, so on this first half, it's all on equations. I need to isolate each radical first. So what would I do to isolate on number 3? Subtract 3. What would I need to do to isolate on number 2? Subtract 4. Subtract 4. Then you'd have negative square root of x equals negative 1. It's still not isolated. What do I still need to do to isolate it? Divide by negative 1. Divide by negative 1. Cancels. Divide by negative 1. The square root of x equals 1. Then you get rid of the radical once it's isolated. You square both sides, right? So on the first half, they're all equations. You got to isolate first, right? Subtract 3 right there. Right here, what would you have to do to isolate? There are 2 things you have to do. Add 2, then divide by 4. And then you could get rid of the radical by squaring both sides, right? So on all these, you have to isolate. Number 11, what do I have to do to isolate? Add 16, that's right. Number 14, what do I have to do to isolate? Add 8. So you guys understand, right? Now, on the, this is a good one. You know what, I didn't explain it. We did the odd ones, but let's practice with this one. Let's isolate. What do I do? Subtract 2. Subtract 2. We end up with 6u minus 5 to the 1/3 power equals negative 5. Now, this is technically a radical, even though it's written as a rational exponent. It's technically a radical. It's technically the third root. And to get rid of the third root, what power are we going to apply? The third power. Yeah, the power of 3. What you do to one side, do to the other. And yes, when you have a power to a power, it eliminates, right? You multiply 3 times 1/3, it eliminates, it becomes 1. So this is really just 6u minus 5 equals, what's negative 5 times negative 5 times negative 5? Negative 125. So then you solve the way you normally would, right? Plus 5, you have 6u equals negative 120, and you guys could do the rest right there. But I just wanted to reiterate that you first isolate it, and then you get rid of the root by applying a power, okay? On the inequalities, it's like doing 2 problems. One problem comes from the inside of the root because it has to be greater than or equal to what? 0. This x minus 1 has to be greater than or equal to 0. And you solve that. Plus 1, x is greater than or equal to 1. There's one answer. The other answer, you solve it like if it were a regular radical equation. You just say, first isolate it. It's already isolated. Second, get rid of the square root by applying a square. And you'll have x minus 1 is less than 4. And then, of course, you add 1 to both sides. You end up with x is less than 5. Those are your two answers. Think about a number line so you can test your answers. 1 is here. 5 is over here. This guy says x is greater than or equal to 1, which is that way. This guy says x is less than 5. Open dot less than is this way. So we need to test this answer that we have here. We're assuming that the answers are in between. So give me a value that's in between. 2. If I plug in, 2's in between. So if I plug in 2, what's 2 take away 1? 1. What's the square root of 1? Is 1 less than 2? Yes, it is. It works. If you tried any one out here, it would not work. Okay. Now, sometimes you get something like this, you test it, it doesn't work, and nothing works, so you would say no solution. Okay. So we're going to spend one more day on this section. I've already made other videos explaining all these other questions. Tomorrow we're going to review the whole chapter, and Friday we're going to have a chapter test.